Hello, my dears, how are you? I'm very fine, thank you. I'm Masnake Halu from Ethiopia. I'm doing my work here in Awasa University as physics lecturer. Now today I will going to tackle the second dynamics problem to you. It says a block is projected up at a 37-degree along a frictionless inclined plane with a velocity of 6 meters per second. The total distance will move up along the inclined plane is, so we requested to find the total distance which covered by the object within the inclined plane. Thus, my dears, can we do together please? Great. Now, solution. Look, first what you have to do, you have to sketch the inclined plane. Let it be, angle is 37 degrees, which is given already over there. Let it be, this is an object which is moving upward. And then what you have to do? We have to split the main force vector, that is mg. So we have to split or decompose mg into its component, that is x component and then y component. And remember, dears, this angle is completely equivalent with this angle. Great. Now the x component of the mg is mg sine 37 degree. That is, let it be wx, which is the x component of the weight of the object. And then its y component is, that is mg and then cosine of 37 degree. Right. And then don't forget this is normal, what you call it, force. As the information is given to us, no frictional force. And hence the only force which acting upon the object is mg sine 37 degree along x-axis. Since the object is moving upward, no input about force, the y component of the force, that's mg cos 37 degree, and ours. B initial is given, that is 6 meters per second. And then B final also given. At the end of this at the end of this journey, while it arrives the end of what we call the inclined plane, it becomes a stop. And hence the final velocity becomes 0 meters per second. Become at rest. It becomes at rest while the object arrives at this point. And then now we have to find the acceleration of the object. To do so, we have to find the net force which acting upon the object, that is mg sine 37 degree only. No frictional force, no applied something other force rather than mg sine 37 degree. And then, as according to Newton's second law, the net force could be calculated as the mass of the object times acceleration, which is equivalent with mg sine 37 degree. But guys, bear in mind, mg sine 37 degree is along left side, but the object is moving to the right. Thus, as we know, force is a vector physical quantity. It must consist of both magnitude and direction, and hence you have to put the sign. And hence, m is cancelled from both sides. And then acceleration becomes negative of g sine 37 degree. As we know, g is 10 meter per square second dot sine 37 degree. Sine 37 degree means 0.6 or 6 over 10. And then acceleration becomes simply negative 6 meter per square second. Great. Bear in mind, this negative sign tells to us the object is not accelerating rather than the object decelerates. And hence, to find the distance which covered by the object, I have to define the distance which covered by the object. We have to use this formula as what we have discussed in our earlier, what we call it, discussion. At the end of this journey, this value becomes 0. And then this is the initial velocity is given, that is 6 meters per second. Just scale it, it becomes 36 square meter per square second. And then minus, because A is negative of 6 meter per square second. And then twice, it becomes 12 meter per square second times S. Now we have to rearrange the numbers. Take to the left, then it becomes negative 36 meter per square second dot meter, which is equal to negative 12 meter per square second times S. Look, negative 1 cancels from both sides. 12 meter per square second by 12 meter per square second both sides. And then S becomes 12 meter per square second cancelled from both sides. Now S becomes by 12 meter per second, this one, 36 meter per square second by 12, 3. Yes, the object covers 3 meters until the final position. Thank you very much. Don't forget, my dears, put your what you call comment up on the box and then subscribe and then follow me. Thank you. See you then.